this is Bentley's mom. Okay, today we're going to do chapter 12, lesson 1. This is the explanation for line plots, which can also be called dot plots. Okay, so we're basically going to do a lot of the stuff we've been doing, mean, median, and mode, and range, and Q1, Q3, and interquartile range in this section. Example 1, it's just teaching you how to draw a line plot. So it says, Jasmine asked her class how many pets they had. The results are shown in the table. Make a line plot of the data, and then describe the data presented in the graph. Okay, so they give all this information. So what I would do first is look at the numbers and try to find from the smallest to the biggest, so we can see like how to draw our line plot. So it looks like the smallest number is 0 and the biggest number goes to 4. So I'm going to draw a line like this. Okay, and this is called a line plot. And I'm just going to go, here's 0, 1, 2, 3, 4. Okay, and you can go 1 extra if you want. Okay, so you want to do kind of equal distance as much as you can when you're doing it by hand. It doesn't have to be perfect, but try to separate it. You always have to keep the same interval though. You can't go by 1s and then all of a sudden go by 2s. That kind of makes the data look different. So here I just went by 1s. Okay, now what I'm going to do is I'm going to mark it using just an X. And a dot plot, you would use a dot. We're going to use X's here. So I would just go through all the numbers, and you can either go across or go down. I'm just going to go down the columns like this. So it says 3, 0, 0, 1. So here's 3, 0, 0, 1. And then I'm going to the second column, 2, 1, 1, 2, 2, 1, 1, 2. And then the third column, 2, 0, 1, 2, 2, 0, 1, 2. And then 1, 2, 4, 3, 1, 2, 4, 3. And then 3, 3, 2, 0, 3, 3, 2, 0. And 1, 4, 2, 2. And we have 1, 4, 2, 2. Okay, so if you look at this, it says describe the data. Okay, well, we can first count the data. It goes 4 down and then 6 across. So there's 24 X's here. So basically what that means is there's 24 students in her class that she asked how many pets do you have. And then you can just write information that you find about this. It's you can say something like, well, the most number of pets that people had was 4. So you can say the most pets anyone had was 4. And then you can say, 4 people had none. So 4 people had no pets. Okay, and then you can also say, if you look at the mode, okay, and this is essentially how bar graphs are made. If you just draw a bar along all these, I like to do that sometimes. It helps me see it better. Okay, so you can see that 2 is the mode. So you could also write the mode or the most people. The mode is 2 pets. So the most people had 2 pets. That was the most common. So you can kind of write any information you want about this, okay? So that's how you draw a line plot. Again, make a system for yourself, or you can go through the data listed and circle all the ones so you know you've used them, because you want to make sure you don't use a number twice or skip one, because you'll make a mistake. I just went down the columns, went that way, and again, you can circle them to know that you've used them. And then just put X's where the data is. Okay. Now, let's go to example 2. Turn the page. Okay, so it says, the line plot shows the prices of cowboy hats. So in this case, they gave us a line plot and not the data. If it helps you at first, if it's hard for you to read the data off the line plot, you can write the data out like we've been doing, mean, median, and mode. This looks like it's going by 5s. It's going 30, then 35, 40, 45, 50, 55, 60, 65, 70, 75. Okay, so for 30, this is the prices of cowboy hats. So all these are prices. So we can put a money sign here if we want. Okay, so there were 2 hats that were $30. Okay, there were 3 hats that were $35. 1, 2, 3. There were also 3 hats that were $40. 1, 2, 3. And 45 also, there were 3 hats that cost $45. And $50, there were 4. So 1, 2, 3, 4. That was the mode. And then there's 1 hat that was really expensive that cost $75. So hopefully you can see that this is the outlier. Okay, so question 2, or example 2 says, find the median and mode of the data, then describe the data using those. So we're going to find the median, which is the middle number, and the mode. Now I could write all of these in a list. I could say 30, 30, 35, 35, 35, 40, 40, 40, and go like this. But we're just gonna do this kind of with our fingers to find the middle or the median using this. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then this one, 16. So there's 16 hats total. So the middle number is going to be between 8 and 9, because if you divide 16 by 2, you go to 8. So I'm going to go 8 this way and 8 this way and kind of see where I meet. So 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th spot. Now if I go from here, remember, don't forget the outlier. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's look down. So there's actually a tie. So there's a tie between 40 and 45. And remember, for the median, if there's a tie, you add them and divide by 2. Okay, or find the number between 40 and 45, which is 42.5. So the median hat price, or the middle hat price, is $42.50, which means half the hats were under that and half were above that. So, okay, the mode is the one that occurs most often. So we can see that 50 had 4 hats. So $50 is the price that occurs most often. And then it says, let's see. So describe. So basically, here's your mode. Here's your median. This is the middle hat price, and then this is the most hats. The most number of hats were $50. You can write that in English words if you're asked to describe it. Then number 3, it says, find the range and any outliers. Okay, so for the range, if you remember what the range is, you take the biggest number and subtract the smallest number. So the biggest piece of data is 75, and the smallest is 30. Okay, and so the range is $45. Okay, so there's a $45 difference between the cheapest hat and the largest hat. Okay, and then the next one is, is there an outlier? And Bentley, what do you think our outlier is?
The 75.
Yeah, 75. So there's one super expensive hat, but most of the hats, were around here, between 40 and $45.
Wait. Then I also have to say this. 30 is around, it's 20 under 50, but 75 is only 25. Does that make it an outlier?
Well, the reason is because between 50 and the data before it,
there's a whole lot of
numbers. So you're going from here to here. Between this one and the next piece of data is only 5. Okay, between this one and the next piece of data closest to it is just 5. But between this and this is 25. Okay, so for it to be an outlier, you're not looking at the one way over here. You're looking at the very next one. See how it's space, 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 and 50? Okay, whereas going this way, that's a good question. There's 35 right next to it. Does that make more sense? Okay, so let's do one more example. Okay, example 4. It says the line plot shows the amount James deposited in a savings account each month. Describe the data, include the measures of center and the variability. So the measures of center are going to be your mean, median, and mode. So basically what this question is asking you is find the mean, median, mode, range. We're going to find quartile 1, quartile 3, and then the interquartile range, and then if there's any outlier. So that's kind of a lot in one problem. So let's start. Let's look at the data. It looks like, so going from this chart, and I'm gonna instead use the graph. I'm gonna write out the data from the graph so you can see. So 35 has 3 X's above it. So that means there's 35, 35, 35. That's what that means. 40 just has 1, so there's 1 40. And by 45, there's 2, so 45, 45. And then 50, there's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then there's 175. Way over here. Okay, and that's how much money he deposited in his savings account. So looking at this, we're first going to find the mean. So you can either take it straight from the line graph or the line plot, or you can write out the data like this and kind of do what we were doing before. It's the same thing. You just need to be able to read it, whether you're giving it in a list or whether you're giving it on a chart or, in this case, a line plot. You just need to be able to pull the data. So the first thing we're going to do is find the mean. Okay, so we're going to add all of these up. Okay, hit enter, and you get 560. And you're going to divide it by how many numbers there are. And there are 12 pieces of data here. Okay, and then you're going to do 560 divided by 12, and you get 46.666, and we're going to round that, so that's 46.67. Okay, so that's the mean of how much he deposited per month. It's $46.67. Okay, now we're going to find the median. Okay, again, and if you use the line plot, you start at each end and kind of count towards. There are 12 pieces of data, so it's going to be between the 6th and the 7th number. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and it's going to be those two, between 45 and 50. Okay, and you can do that on a line plot. Just follow the X's from the lowest and then the highest, and you'll meet. And it's a tie in this case, so remember you add them up and divide by 2, but hopefully you can see what's the number between 45 and 50. It would be 4750. Okay, so that's the median. And then we have the mode, which is the number that occurs most often. Okay, and looking at this, it looks like we have a bunch of 50s. We have 3 35s, but we have 1, 2, 3, 4, 5 50s. Okay, so 50 is our mode, the number that occurs most often. Okay, and then, so when in the question, when it says include measures of center, these are the measures of center, your mean, median, and mode. So when it asks that, that's what it's asking for. And then it says, and variability. So the variability, let's go through our range and our interquartile range. So our range is going to be the biggest number minus the smallest number. So it's going to be 75 minus 35, which is 40. That's our range. And then our quartile 1, remember, is we took the median, which is in between there. Okay, and then you're going to find the median of the lower half, the middle of the lower half of the data. So you go 1, 2, 3, 1, 2, 3. So in this case, it's a tie. It's in between 35 and 40. So you do 35 plus 40 divided by 2 is technically what you're doing. Hopefully you can see the middle number between 35 and 40 is 3750. Okay, this is all money. And then for quartile 3, okay, we're going to do the same over here. Again, here's the median. So you're going to go 1, 2, 3, 1, 2, 3. It's in between those, and those are the same number. So the number between those is just going to be 50. And technically you're doing 50 plus 50, which is 100 divided by 2, which gives you 50. Okay, so now to find the inner quartile range, if you remember the range is the biggest minus the smallest, but for the inner quartile range, you do Q3 minus Q1. Okay, so we're going to do quartile 3 minus quartile 1. So we do 50 minus 3750. And is this too low, Bentley? Can you see it? And we get $12.50. Okay? And then the last one is the outlier. Okay, and so let's look at this data. Okay, now between the 35 and the next data 40, that's not very much. But between 50 and 75 is 25. That's big. So 75 is going to be our outlier. Okay, and that is what they're asking you for. Now, if it asks you to describe things in words, you could just write, like say, for example, the range, what that is the difference between the highest and lowest amount he deposited was $40. So you can kind of make statements. The average is $46.67. The middle is $47.50. You can kind of use English words to describe, the mean is the average, then the median is the middle, the modes, what occurs most often, etc. Okay, so that's it for the explanation. Okay, bye.
Bye.